I'll begin today's conference. I'll turn the call over to Aileen with MSC. Please go ahead.
Hi, everyone. Thanks for joining today's live webinar. My name is Aileen Riley, and I'm the Category Specialist for Safety here at MSC. We're very excited to partner with SHOWA and offer this webinar about industrial-grade biodegradable gloves, presented by Matt Piotrowski at SHOWA. We at MSC are very sensitive to the current climate the COVID-19 pandemic has created, but want to be clear that we are not medical or infectious disease specialists. MSC has been deemed essential by the U.S. government, and we are working hard with our supplier partners to support our customers' needs. With that being stated, when we open the line for Q&A at the end of the webinar, we will do our best to answer all supply chain and PPE related questions, but we ask you reach out to your MSC sales associate about placing orders. Matt, the floor is yours.
Thank you very much, and welcome everyone to this MSC webinar. We here at SHOWA would like to thank MSC for inviting us to partake in this session, and we'd also like to thank everyone joining us as attendees on the web. Today we're going to learn about biodegradable technology and hand protection and how SHOWA pioneered this new segment of the glove industry with our EBT, or EcoBest Technology. Today we're going to cover the basics on biodegradation, the impact of traditional disposable methods of single-use gloves or disposable gloves on our environment, how biodegradable gloves can affect positive change, how EBT technology actually works, and the performance characteristics of biodegradable gloves versus traditional disposable or single-use gloves. I'll be using the term single-use gloves fairly significantly in this presentation. It just refers to the same nomenclature as the disposable glove, a traditional disposable glove. So first question we have to ask ourselves, what is biodegradation? Some people may have a limited or incorrect understanding of the true definition of biodegradation. So a very simple way to define biodegradation is this: the decomposition of materials by the action of naturally occurring organisms. So essentially microbes breaking down items into base compounds or elements. We have to remember the scientific law called the law of conservation of mass and energy. And it states, matter and energy is neither created nor destroyed. The total amount of mass and energy in the universe is constant. So when something biodegrades, that item is broken down into other components that return to the earth in other usable forms. Think of a leaf falling from a tree and resting on the ground. Over time, that leaf is going to be consumed by microbes in the soil on the forest floor and broken down into base elements and compounds, return to the earth, and complete the life cycle of plant growth. Now, we hope that gloves aren't disposed of on a forest floor, and I think that all of us can conclude that most gloves are disposed of in a more traditional manner of throwing them in a waste bin or a trash can. That waste is then collected and transported to a landfill, and this is where SHOWA's EBT technology begins to work its magic. When items are disposed of in a landfill, there are plenty of microbes present to help facilitate biodegradation. But the important next question is, how long does it take for that object to completely biodegrade and return to the earth? Here's a good representation of some familiar objects that we're all exposed to on a daily basis. So for instance, you can see there's the banana peel, 2 to 10 days, fully biodegraded. Paper, a handful of months. Bone, a decade or more. Plastic bags, 80 to 150 years, and this is the big topic in New York State and in California and some other states as well, where they're banning the use of plastic bags in point of purchase areas such as grocery stores and convenience stores and that kind of stuff. So very interesting to see. You can see the reason for that is it takes over 150 years in some cases for a plastic bag to fully biodegrade. As you come all the way down to the bottom of that list, you'll see a glass bottle, 4,000 years. We're talking about biodegradation that's measured in thousands of years, millennia. So very long time periods when it comes to this. But the real focus here for the purposes of this presentation is over here on the left. Standard 4-mil nitrile glove that pretty much everyone would be familiar with. I'm going to use this laser pointer thing here, over here. Pretty much everyone's familiar with this. It takes roughly 100 years or more for that 4-mil nitrile glove to fully biodegrade in a landfill. Gloves that are thrown away today that are not biodegradable will still be around in the year 2070, the year 2080, and even longer. Great visual representation of the glove usage and disposal globally on an annual basis. Over 100 billion gloves are thrown away each year. And that number is actually probably on the low side. It's an estimated number. Enough to go around the moon and back 30 times. And if it were laid out end to end continuously, that's 13.2 million miles long, or 150 or 130 trips around the globe. When we see the sheer volume of gloves that are disposed of annually, it's staggering just to look at the average weight of a 4 mil nitrile glove at around 5 grams per glove. That's about roughly 1.1 billion pounds that are thrown away each year globally, roughly the weight of 5 Nimitz-class aircraft carriers. So as you can see, the issue of gloves being disposed of in astronomical amounts every year, and most of those gloves taking over 100 years to fully biodegrade, is an issue that needed to be addressed for the benefit of our planet and for future generations. So about 5 years ago, being an environmentally conscious company with green initiatives of our own and wanting to help our customers implement their own programs, recognized this global issue and in turn pioneered a new technology to help combat the issue and speed up the process of biodegradation for gloves that have been disposed of. This technology is called our EcoBest Technology. You can see the logo there. So how does EBT work? Very simple, actually. So EBT technology is added to the nitrile mixture during production of the glove at the factory. Gloves are then shipped out to our facilities and distributed to our customers. Important to note that EBT gloves will not biodegrade on the shelf or during use. It's a common question that we get. The biodegradation does not start until it's introduced into an active landfill. Okay, so keep that in mind. The gloves are then used at the end user level and they're disposed of. These gloves are then collected and transported to a landfill, by a garbage truck or refuse collection. And again, this is where EBT begins to work its magic. The microorganisms in the landfill are attracted to the gloves with EBT material in them, and they begin to decompose them. The rate of decomposition is drastically accelerated in an EBT glove, and within 1 to 5 years, the glove has been completely decomposed, whereas traditional non-EBT nitrile gloves take over 100 years to fully decompose. The process of biodegradation has an end result producing organic soil, water, and biogases. And we're going to talk about that in a little bit more depth. So let's elaborate on those end results, okay? So when a nitrile glove biodegrades, it will leave behind the following organic compounds. Okay? Organic soil, also known as humus, is a popular name for it, or unpopular name for it. Water, carbon dioxide, and methane. All right, that's what's going to be left behind after a glove as it's biodegrading. All 4 of these things can be reintegrated into the earth in various fashions and properties, which is necessary for the growth of entities such as plant life. So the big question on everyone's mind, how does EBT contribute to the environment? Well, we saw that hundreds of billions of gloves are discarded in the trash every single year. And like most other plastics or oil derivatives, they take hundreds of years to degrade fully. EBT is designed specifically to drastically accelerate the biodegradation rate of nitrile gloves in landfills. The microbes within the landfills excrete enzymes that break the polymer bonds of the nitrile and decompose it into easily digestible elements. The end result of all of this, simple natural elements such as organic soil, water, CO2, and methane. Okay, now, SHOWA being as focused as we always are on our innovation and our technology for hand protection, we wanted to be sure that we backed up every single one of our claims on EBT with hard and true testing based on the accepted test methods in today's standards. So we're going to talk about that a little bit here. The first test we're going to discuss is ASTM D5511. We'll just refer to it as 5511 as we continue to talk, which is the standard for determining the biodegradation of plastic materials under high solids and anaerobic digestion conditions. Pretty long-winded there, but the key word here being anaerobic, which means no oxygen. Okay, in today's modern landfills, trash and refuse are normally covered with soil in layers, and because all this trash is actually underground to some extent, and being that it's underground and buried, there's not oxygen present. The test is performed using a bioreactor with a high solids concentration, meaning the percentage of waste or trash to water during the test is very high. An easy explanation of this, The higher the amount of solids or trash, the higher the amount of microbes that are going to be present. Okay, so we're going to take a look at the graph here for this. This graph illustrates the percentage of biodegradation of specific types of glove under this test method. Note that the test is conducted over a period of 157 days total. So the key lines to focus on first are the red lines and the blue lines. The red line represents a standard disposable natural rubber glove. Okay, and as you can see, over a period of 157 days, the natural rubber product did not biodegrade at all. Okay, so a lot of people think that just because we refer to natural rubber as natural, that it will return to the earth. But as soon as you start curing it and vulcanizing rubber, it becomes very non-biodegradable. It takes a very long time for it to happen. The blue line represents a standard 4 mil nitrile glove, which we're all familiar with, very popular in the industry. And as you can see, over the same period of time, that glove had only biodegraded less than 3%. And the line is very flat and trending in that same flat trajectory. Now focus on the two green lines, which represent 4 mil nitrile gloves and a 15 mil nitrile glove with our EBT technology added to it. As you can see, over the 157-day period of this test, EBT gloves were biodegrading up to 16% in that short period of time, clearly illustrating the power of EBT. The next test we're going to look at we're going to focus on is D5526, which is the standard for determining anaerobic biodegradation of plastic materials under accelerated landfill conditions. Keyword here again being anaerobic, which means no oxygen. So again, we're talking about trash being piled up in a normal modern landfill. The good thing about this test method simulates more real-world conditions in a modern landfill, and it covers a much longer period of time. It's going to be over a year worth of results. Okay, whereas before the previous test was done with a bioreactor, this is going to simulate more so a modern landfill environment. Again, this graph that we're looking at here, it illustrates the percentage of biodegradation of specific types of gloves under this test method. Okay, and it's going to be done over a period of 1.1 years. Note that the testing is conducted over that time period of 1.1 years, and it's conducted in an environment more conducive to an actual landfill rather than that bioreactor we were talking about. Key lines to focus on here first, yellow and red lines. I want to introduce that yellow line. Because this test is performed using landfill conditions, we need to determine if there are microbes present in the soil or the landfill that they're actually using, and that those microbes are healthy and active. So the yellow line represents a positive control, something considered highly biodegradable, in this case a wood or a cellulose material. And from the line on the graph you can see the microbes are healthy and active. And then the red line, which we'll take a look at, represents a negative control, something deemed not very biodegradable. In this case, that negative control is a polyethylene material. And you can see its line is flat, nearly no biodegradation over the course of 1.1 years. Now, take a look just a teeny bit above that red line is a blue line. Now, this line represents a standard 4 mil nitrile glove, a non-biodegradable 4 mil nitrile glove. Again, you can see nearly no biodegradation over the course of a full year. Now, I really want you to take a look at the green lines in the center of the graph. This is where the meat and potatoes is here. These lines represent SHOWA 4 mil nitrile gloves that have had EBT technology integrated into them. Look at the percentage of biodegradation over the course of 1 year, between 38 and 75% in 1 year of biodegradation. And depending on the amount of solids present, and remember that the higher the solids content, the more microbes are present in that particular test. Now compare that to the standard non-EBT nitrile gloves. Still got over 100 years to biodegrade. The EBT gloves will be gone in 5 years or less. I mean, these results kind of speak for themselves, clearly illustrating how effective EBT technology is. The third test we're going to look at, this test method SHOWA also performed was ASTM 1963, which is a toxicity test for terrestrial plants, which basically displays the effects of the components in which a nitrile glove degrades into. What effects do they have on plant growth and development? We chose three common crops, corn, soy, and pea, which represent a large portion of agriculture in this country and abroad. And this test is going to help us determine if we were doing any harm to the environment and plant life while our EBT gloves are biodegrading and after they have fully biodegraded and returned to the earth. First, we test the seedling length of each type of plant. Okay, so seeds are planted in normal, regular soil, so consider that the control. They're planted in soil with biodegradable EBT materials, and then they're planted in a contaminated soil, and essentially the soil is contaminated with a boric acid, something that we know to be a known contaminant. And as you can see from the results of each plant, the length of seedling growth of each plant type was not really affected by the soil, which had EBT in it. Second, we tested the germination percentage of those three plants. Essentially, how many of the seeds that were planted actually germinated and sprouted? What percentage of those grew? Again, we used the three types of soil as the same previous test. And as you can see here as well, there were no real negative effects on the germination percentage of the seeds either. Further proof that not only does EBT speed up biodegradation rates dramatically, it also does not create any toxicity to the environment during or after the process of biodegradation. Now, we talked early on about one of the byproducts of biodegradation of nitrile gloves is methane. And some people may refer to or see methane and get a little concerned about it. Sometimes methane gets a bad rap. All nitrile gloves will regardless of construction, will release methane gases as they biodegrade. The faster a glove biodegrades, the faster it produces that methane gas. So biodegradable EBT gloves help to release methane gas up to 8 times faster than traditional nitrile gloves. This helps in the increase in the collection efficiency of methane in landfills, which in turn allows us to generate more power and electricity faster. And to the left is a basic diagram of how methane is collected in a modern landfill. And what we're going to talk about is all the good things about methane and the things that we're actually figuring out that methane is actually very helpful and useful for us in creating energy. Now you may ask yourself, what's so great about methane, as we were just saying? Well, methane is a combustible gas which burns very cleanly, and hence can be used to generate inexpensive power and electricity. Gloves are not the only thing in the landfill that produce methane as it biodegrades. Nearly everything in the landfill creates methane. So most landfills today, they're collecting that methane gas for use in energy production, selling it off as energy production or using it directly as energy production. As you can see, nearly 75% of all municipal waste in the U.S., it's being placed in a landfill that collects methane for energy use. Okay, so now you may find yourself asking further, explain this to me, how does methane create energy? And this simple diagram here is going to illustrate from start to finish how that methane is collected at the landfill. You can see the bulldozer pushing the stuff into the landfill, the things biodegrade. While it's in the landfill, the methane gas is created, it's extracted and cleaned. That gas is then sent to gas turbine engines and electric generators and transformed into clean energy for use in powering homes, hospitals, airports, businesses, etc., all over the place. Now, maybe you're not familiar with anyone using methane energy. We'll take a look at this picture and tell me that you don't recognize at least a handful of companies listed, if not more. Some very large multi-million-dollar corporations that we are all exposed to on some level, I'm sure, during our lives. And this only represents a small fraction of the companies who are actually using methane gas. So all of these well-known, well-respected, industry-leading companies are using landfill gas, methane essentially, to power their own operations. Their own green initiatives help them learn the power and importance of landfill gas energy production. Now you have a chance to contribute to that cycle and those green initiatives by using EBT gloves, which help to produce that methane gas, again, 8 times faster than traditional single-use gloves. Now, big important questions. How does EBT perform during use in comparison to standard nitrile gloves? How do they perform against chemicals in comparison to standard nitrile? How is the shelf life and storage of EBT gloves in comparison to standard nitrile? Well, the upfront and easy answer to all these questions is very simple. They are the same. Same physical properties in terms of elongation, tensile strength, comfort, fit, same chemical resistance and permeation rates of standard nitrile, and in some cases better. We're going to take a look at that here real fast. You can see here the comparison of a standard 4mm nitrile glove versus EBT nitrile gloves in terms of tensile and elongation. Very similar results with negligible differences between the two. The green being the EBT glove, the gray columns being the standard nitrile glove. We'll go a little bit further. Here you can see chemical permeation rates of certain common chemicals that we chose. These are fairly common chemicals used by people who are using single-use gloves in an end-use application. Standard nitrile here represented by the gray line and EBT nitrile represented by the light green line. Nearly identical chemical permeation results. The dark green line represents EBT nitrile gloves which have been aged for 18 months, meaning they've been sitting on a shelf in a warehouse for 18 months in their dispenser pack, ready to be used. The interesting thing about nitrile is that it continues to cure and strengthen its cross-link structure even after the glove has been packed into a dispenser box and put on the shelf, therefore increasing its chemical protection over time. So as you can see, the performance of EBT also increases over time. Now, what does aging do to the physical properties of EBT gloves? Well, as you can see from this slide, which again represents a standard unaged nitrile glove versus an 18-month aged EBT glove, its physical properties remain unchanged, and in some cases, a little bit better. So what do all these results show? They tell us that an EBT biodegradable glove performs the same as standard nitrile. It fits and feels the same as a standard nitrile. It can be stored in the same fashion as standard nitrile. It has the same chemical permeation rates as a standard nitrile. Essentially, it's as good, if not better in some cases, as the industry standard 4mm nitrile glove in every aspect. Now, let's take a moment and take a quick look at some of the actual products that SHOWA offers in their EBT line in conjunction with MSC. As you can see here, there's a well-rounded complement of single-use gloves in the 4mm category, green and black, and of course the ever-popular blue. Also, a newer addition to the EBT lineup is our 2.5mm glove, the 7502, which is an accelerator-free glove. And that helps with those people who have skin irritations, even while using nitrile gloves. Some of the accelerators that are used sometimes in the production of nitrile gloves can actually cause skin reactions in people who wear nitrile gloves. Some people have a natural reaction to some of those accelerators. All right, so the accelerator-free feature on this product, it helps to significantly reduce this. And also, this glove is recognized as one of the finest thin-wall single-use gloves on the market today. And some of the fresher faces to the EBT lineup for SHOWA and MSC, a pair of cobalt blue 4mm and 8mm styles with very low AQL levels. AQL translates into very, very high quality. It's probably the best way to explain it without getting too technical. The lower the AQL, the higher the quality and the consistency of the glove. So the closer that number comes to 0, the better the quality is. And also there's a fresh green colored 4mm, which is also accelerator free again too as well. So for those people who have skin sensitivities to the accelerators. And then rounding out the EBT category, our thicker mill products are more recognized as multiple use or chemical resistant style gloves, which are popular in a lot of industrial food processing environments. We've even started to put the EBT technology into cotton poly supported gloves, such as our NSK24, very popular lined chemical gloves, been around for many, many years. It's now has that EBT properties as described in this session. So we're starting to build on and continue to work towards the EBT line growing and the technology being implemented in as many cases as we can. So in closing, how again does EBT contribute to the environment? It increases the biodegradation rate of disposable gloves and allows the glove's end component to return to the earth in other usable forms. Again, we're talking about organic soil, water, carbon dioxide, and methane. Speeds up the production of that methane up to 8 times faster than a standard nitrile, helping to produce that clean, inexpensive energy faster. Companies who are looking to reduce their carbon footprint by adopting green initiatives, ISO 14000, EBT technology may contribute significantly towards their efforts. And the final, it gives the old typical 4mm nitrile glove an exciting new story to tell. This is something now that you can take to your customers and show them something different rather than just, oh, it's another glove and another 4mm glove or disposable glove in a dispenser box. you have a new story to tell, and it's a great story that not only helps you but also helps the environment. So that concludes the presentation portion of the webinar. I'd like to hand it back to Aileen.
Matt, thank you so much. That was incredibly insightful. So I do want to open up the floor to questions so we can take questions that came through the Q&A chat and then open up the phone lines. And I do want to note, we also have Brian Mosley from SHOWA, who is a panelist as well, and he's the Director of Research and Development to help with any technical questions. So the first question here is from Jeffrey Merkel. Says, is biodegradation the same as composting?
That is a great question. Biodegradation and compostability are two separate things, but they're also similar. So we have to remember that biodegradation would be, if we were to look at a large circle, biodegradation is the large circle, and we take compost or compostability and we put that in it. So anything that's compostable is technically also biodegradable. It's doing the same thing essentially. But anything that's biodegradable is not necessarily compostable. Really where compostable comes, and I believe the standards for compostable are D6400 in ASTM and EN 13432 for Europe. In order for something to be compostable, it has to biodegrade, I think, at least 90% in 180 days in order for it to be for it to be considered compostable. So, Brian, do you have anything else you wanted to add to that?
No, end components should be the same. It's the time to get to those end components. And you'll see different times on compostable depending on the agency that you're working with. But no, very good.
Awesome. Thank you so much. And it looks like there was another question that says, can a price list of all the biodegradable gloves be sent to the attendees from Linda Finch? So we'll actually let Rebecca Avery from MSC answer that question.
Good afternoon, guys. Yeah, I will work with SHOWA to create a sell sheet for MSC of all of their lines of nitrile single-use gloves that are biodegradable. Just give us a few weeks, and we will get that sell sheet out to everyone.
Thanks, Rebecca. And it looks like we have another question here about manufacturing locations for these gloves. If we're able to share that information, I'm not sure, Matt or Brian, if we can.
Brian, you want to handle that?
Well, as the product line grows, it's through plants globally. I mean, that's probably about the best way to put it, because we've got processes that's been in certain plants for, a few years, but it's just growing tremendously that we're looking at other SKUs, newer types of products in other plants. So really it's taking, pretty much all of our plants to start manufacturing these.
And just to maybe ease everyone's mind, nothing that SHOWA makes comes from China. So we do not produce or manufacture or buy anything from China.
Okay, thank you both for the transparency. It looks like we have a couple internal MSC questions that I can handle offline. And I do want to remind everyone about the giveaway. So we'll open up the line now if anyone has a question they want to call in for. And then after that, we'll announce the giveaway winners.
If anyone wants a verbal question, please go ahead.
Doesn't seem like anyone on the phone line has a question. It looks like we just have one last question in the Q&A section that says, is SHOWA looking at adding EBT technology into the reusable chemical and cut protection gloves?
Yes, I mean we're looking where EBT can possibly be used. One of the things that you get with the chemical resistant glove, Matt, the last product that he showed was the NSK-24. So that gives you an idea about how we're entering into those heavier uses within the chemical sector. It's got some great chemical protection data on ChemRest, as well as the 728 version as well. That's the 15 mil nitrile. So the answer is yes. We're constantly looking where else can we utilize this technology to make it work from a production side. On the cut side, the answer is yes. The problem you get into there is you've got some fiber considerations. That's a much longer project. But the answer is yes. We're continually looking at that simply because of the green initiatives and our commitment to the environment.
Yeah, great answer. It's something that we recognize that it's not just only single-use or disposable gloves that are being thrown away every year. As glove manufacturers, we like to think of all of our gloves as disposables. So at some point, all those gloves are going to end up in the in a modern landfill environment. So we continue, as Brian said, continue to innovate and try and find ways to implement this technology moving forward into everything that we do, and hopefully we'll be able to continue. We've got some great things going on right now in development on styles that would be more traditionally an industrial style glove rather than a chemical or single-use glove that we'll be rolling out with EBT as well. So stay tuned for some of those great new products coming from SHOWA as well.
Awesome. Thank you so much. We look forward to seeing all those. So I do want to thank Matt and Brian so much for the presentation and answering all the questions that we had. It was very insightful, a ton of good information. So I do want to say if anyone has more questions or wants to see this again, it's going to be up on the Better MRO site. And also feel free to ask questions in forums at Better MRO. And now I do want to say the two winners for the giveaway. So drum roll, please. It is Julie Reynolds. Oh, there we go. Julie Reynolds and Stephanie Romo. So we will follow up with you offline about how to go about getting this awesome giveaway. So again, thank you all for participating today. And please be sure to check mscdirect.com/BetterMRO for the latest trends in the safety industry. Thanks again.
Thank you for joining today's conference call. You may now disconnect.